In the previous video, we had learned the three rules that are followed for filling up the electrons, or rather, to give us the electronic configuration. In this video, we are going to be discussing about the electronic configuration and how we should be doing that. So first of all, the distribution of electrons in various orbitals is called as electronic configuration. And there are two ways by which we will write it. The first one is, instead of, so here, I will be, instead of writing it and showing it to you as it's intended to, I'm going to just write it for hydrogen. So hydrogen, as you know, has one electron. Okay, so which means it has one s1. Also, it can also be written as 1s. So these are the two ways by which we will denote a particular configuration. So this, first of all, this is the principal quantum number. S is the subshell and the number of electrons is given as 1. Now, in case of the orbital diagram, you have this is by basically writing the principal quantum number is written before the subshell and then you're filling in the electrons respectively. So, for an electron to be represented, we will be using the upward arrow or the downward arrow. If you remember, when we talked about the magnetic spin quantum number, we said that each orbital can either have a plus or a minus spin. So, this orbital is full. So, I can't fill in like, okay fine, let me just add, okay. This is wrong. We need to have only 2 electrons in an orbital, and not only that, they both should have the opposite spin. So this is also going to be wrong. This representation is also wrong. So one will be upwards and the other will be downwards. So instead of telling you that, okay, these are the rules that we have to follow to fill in the electrons, let's do elements from lithium to neon. Okay, one more important thing we need to remember while filling the electrons are the 3 rules. That is the Aufbau principle, Pauli's exclusion principle, and Hund's rules of maximum multiplicity. If you don't know these things, do check out the video that we had done where I discussed all these 3 rules in detail. Now, let's start with lithium. Now, lithium has the atomic number 3. Okay, so which means that in its 1s shell, it will be full, so 1, 2, and 2s shell will be half full. So this can be written as 1s2, 2s1, where this 2 represents the number of electrons in the orbital, and this represents the principal quantum number. Next, beryllium. Beryllium has the atomic number 4. So 1s full, 2s is also going to be full. So 2s, 1s2 and 2s2. Here the 2p orbital is going to be empty. Next, barium, boron. Boron atomic number is 5. So 1s full, 2s is also full, 1, 2, 3, 4. So in the 2p orbital, you will have 1 electron. So 1s2, 2s2, 2p, 1. Boron, carbon. Carbon's atomic number is 6. So first let's fill in 2 electrons in the 1s orbital. Then we'll be filling 2 electrons in the 2s orbital. Then we'll be filling 2 electrons in the 2p orbital. So here remember, we will not be writing it as, okay, let's just fill this 2 orbitals. No. The reason being, all 3 orbitals in the 2p, in 1, 2 and 3, all these orbitals have the same energy. So each of these will be first filled. So you will be filling this and then we will pair it up. So you have 1s2, 2s2, 2p2. Here, okay. Next, carbon, nitrogen, whose atomic number is 7. So nitrogen, 1s is full. Then we'll fill in 2s, which is also full. Now 2p, We will not be pairing up the electrons, but we will be filling in the individual orbitals. Okay, individual individual orbitals. So 1s2, 2s2, 2p3. Nitrogen, oxygen. Oxygen's atomic number is 8. So here you have 1s paired up. 2s will also be paired up. Now 3p. Here we will start pairing the electrons because here all the 3 orbitals were full, so the 4th electron was added over here. So 1s2, 2s2, 2p4. Oxygen, nitrogen, nitrogen, oxygen, fluorine. Fluorine's atomic number is 9. So I'm not going to draw. Okay, so here instead of just like having 4 electrons, it will have the 5th electron. So its configuration is 1s2, 2s2, 2p5, and neon's configuration is 1s2, 2s2, 2p6. So here, if you notice, we kept adding electrons in the p orbital. Now this is also, so, and we didn't do, okay fine, 1s, let's just do 2p and then let's do 2s. No, this is based on their increasing energies. So because of that, we need to start from 1s, go on to 2s, then 2p. I think we discussed about the increasing energy of the orbitals when we had spoken about the various energies of the orbitals. So they are filled based on their energy levels. Now if you look at the periodic table, you will notice that you have the alkaline earth metals and the alkaline metals on the left and the noble gases on the right. Now these noble gases have their electronic configuration full. Now for after neon, what is the next element is sodium. Okay, so sodium has the atomic number 11. Okay, and the new electron will be entering into its S shell, that is the 3s shell. So its configuration is 1s2, 2s2, 2p6 and 3s1. Now this portion of the configuration is similar to that of, or rather is the configuration of neon. So this can be represented as Ne bracket 3s1. So basically we are just going to be taking the closest, or rather the previous, closest means I can't just take, okay, fluorine is very close to neon, so fluorine's configuration is Ne and 2p5. No, the previous one, the previous noble gas that is taken, and the newest electrons are added onto the that is the principal quantum number, or rather the shell to which the electrons are newly added is represented beside it. So here there are 2 different types of electrons. These are called the core electrons, whereas this is called the valence electrons. If you remember, you had learnt about the concept of valency in grade 9. So there you had understood as to how electrons are lost and gained. But here we are talking specifically about the number of valence. If you see, the correlation will be there even now. There we said the valency of carbon is 4. Here also it will be 4, right? So that, I mean, we will be discussing about the stability of the half-filled and completely filled electron shells later. But here you need to notice, or rather remember, that the ones in bracket are called as the valence electrons and these are the core electrons. Now in our periodic table, as we go from scandium to zinc, in case of scandium we will be having D shell. So scandium's electronic configuration becomes argon and 4s2, 3d1, because the energy of 4s is 4p is higher than that of 3d, so we will fill in the 3d orbital and then we will go on to fill the 4p orbital. So zinc's configuration is 3d10, and then from when the 3d orbital is full, we will be filling the electrons in the 4p orbital that is from gallium to krypton. Rubidium to xenon, we'll be filling in the 5s, 4d and 5p, similar to that of what we had observed for neon to argon to rubidium, argon to krypton. Next, lanthanum to mercury will be filling in the 4f and 5d orbitals. So 4f has 7 subshells and 5d has 5. So then we'll be filling in the 6p, and then after that we'll be filling in the 7s, 5f and 6d. Now after uranium, all these elements are very short-lived, and so they are synthesized in the lab, and so they're not particularly stable. They get they collapse, or rather, so they're not very stable. So the electronic configuration, it might feel a little difficult right now, but this forms a very important part for reactions. Not only that, the electronic configuration is the basis for the periodic table. So if you understand the electronic configuration, you will be able to understand the periodic table itself. It becomes very easy. So just remember the 3 principal rules. Okay. Remember that we will first fill in half and then pair it up. Okay, remember that the energies are from low to high, and that's based on the energies that we had learned in the previous videos. So that is in the order, that has a particular order. So I can't just fill in 1s and then go to 2p and then do to 2s. No. So we'll be doing 1s, then we'll be doing 2s, and then we'll be doing 2p. So that is very important, and I'd suggest, if you find it very difficult to do the electronic configuration, in the textbook, in the end of this lesson, you have the electronic configuration of all the elements in the periodic table. Do check that out, compare it with the energy level diagram, and figure out, write down the energy level diagram in your book. Parallelly have your atomic numbers along with the elements open, and then start filling in. And the moment you start doing that, you will be able to understand the electronic configuration. With that, we finish the electronic configuration for the atom. In the next video, we will be discussing about the half-filled and completely filled orbitals.